What is I squared? Minus 1 times minus 1, which is 1. That's all I ask you to do. I'm not asking you to bring in square roots. So, quickly, I'll work out 5, 6, 7, 8. How do you get 1? Can you first write I to power 4, not just 1? You're not going to learn if you try to just write short form of something. Because if you forget, then you won't remember how you did it. Just stop writing short form. Oh, I know, it's going to be 1 times this. How did the 1 come about? Write it down. Okay, we should stop now because of time. I want to get to the next 2 things that I want to discuss. This is basically introduction. We'll get to the core of the whole thing tomorrow. So, has anybody done 5?
Yes.
So, I what? I 4.
Times
And what is I for? 1. 1 times I is I. What about 6? 5 times, so which is I times I squared. What about 7? Can do I 6 times I, right?
Yes.
Which minus 1 times I minus I, yes?
Yes.
And 8, I 7 times I, what's I 7? Negative I, and you get negative I squared, which is negative negative 1, which is 1. What do you notice, anyone? Same does not explain anything. You say what? That's what I want to hear. Not same. Same words. Okay? What pattern do you notice?
I to I4 is basically I5 to I8.
So what is the pattern? I negative 1, negative I, exactly. So we can see the powers of I form a pattern. Okay, so that will be the conclusion. Let's put that here. So I can say I to the power n, right? Gives a pattern. And the pattern is I negative 1, negative I, right? And 1. So, what do you notice? So there is the positive I, negative 1. Then opposite of these two follow. Okay? I is always positive. The next one is negative 1. Then the next 2 is exactly what you have, but in the negative form. So the negation of this is this. The negation of this is that. Because I'm going to ask you next, what is I to power 2019? Let me know if you figure it out. I to power 2019. Yeah, this year is 2019, that's why I chose it.
Minus I.
What?
Minus I.
Correct. How do you do that?
I divide it by 4, and then you find the remainder. The remainder is
Exactly. Just when this year I will do it. The next leap year is next year, 2020. So if I get to I to power 2020, I come backward once. And 2020 is this last one. So 2019 must be this one. Does that make sense? So I go to power 4, then I can reverse. If my power 4 is maybe here and I have maybe 1 extra, then I know the 1 extra is the next one here. Like maybe I give you I to power 2021. So if I'm going to do something like this, plus maybe I to power 2021, of course you know this is negative I, right? I to power 2020 is this, then 2021 will be, come back to the cycle, right? And that will be I, right? And the answer will be 0. Without the use of calculator. You should be able to remember this pattern. Let's take note of that. So, then this example will follow. So before we move to the Argand diagram, does anybody remember this word? Conjugate. We talked about this in. Okay, remind me. What do you know that? What do you remember about conjugate?
A plus B squared, right? Yeah. B squared.
Anything C.
C,
And then
Equal no times. No.
what do you mean by this? I'm just writing what you said. I'm not acknowledging anything.
Isn't it A plus B bracket B?
You mean like this?
A minus B C
So what do you mean by this?
equals
The
A
second
squared.
one is multiplication.
A squared minus
What you have just told me is difference of 2 squared. You have not explained conjugates to me as a beginner, for example. So what do you mean by conjugates with everything you have just said? Yeah, that's what I've just done times.
Multiplying pairs, conjugate pair.
So-
Eliminates the surd.
Now what you have just said is multiplying something, right? I'm asking you that thing itself. I'm not asking you for the multiplying whatever. I'm saying I saw the word conjugates and I don't know what it means. Well, how would you tell me? I mean from 1.
flip the sign.
What?
Sign in the middle.
The sign in the middle is called conjugate?
To cancel all this.
Do you understand the question I'm asking you? You are talking to me like I have an idea. I'm asking you like I don't have an idea. I'm in P6 or Form 1. I'm your sibling. I saw it in your notebook and I ask you what is the meaning of the word conjugate. How do you explain to me? You cancel the denominator? No.
The product of two conjugate terms is always a regular.
Okay, so the question is what is conjugate? Just tell me, oh, a Chinese man is it? I'm asking you who's a Chinese man. I'm not asking you what they can do. And I don't want you to look at the notes. Yes?
In a conjugate pair, one is the negation of the other.
In the conjugate pair,
One is the negation.
one is the negation of the other. That's close to the truth. So one of the things we need to learn is how to answer questions. I'm asking you for conjugates. You are telling me this. This has nothing to do with the meaning of conjugate. You are only explaining the property of conjugate. You are telling me, oh, Damien or maybe Brandy is tall. I'm asking you, is Brandy? Because there may be so many tall people. Do you get the point now? So, simply put, the conjugate of this third is this one. And the conjugate of this one is this one. You don't have to even multiply or tell me to open a bracket. The conjugate of the third is that same third with a different sign in the middle. That's all. You don't have to bring in, okay, open bracket, multiply. I don't need that because I didn't ask you that. Do you understand? This is just the property of the conjugates of conjugate third or conjugate pairs. So similarly in complex number, let's write the complex conjugates of a plus bi, can somebody guess, is
A minus B.
what?
A minus B.
A minus bi. Just like so. And later we will see that the product of two complex conjugates will never be complex. Product of two complex conjugates will never be complex. You know why now? Because when you multiply the I squared, it becomes a real number. Okay? Later we will see that.
Oh, yeah, I saw it.
Aha.
I square is real number. Wait, no.
Okay? We'll see that later. We'll work with that very much later. In the last 2 minutes, I will introduce the Argand diagram, and that's where we start. We'll be able to go into the modulus and arguments tomorrow. We won't be able to do that now. Some G's like that. Anyway, so this is just a graphical representation of complex numbers. Okay? This diagram or should I say geometric representation? In a two-dimensional plane. Okay? So basically, we have our x and y axis just like we usually have. But our y axis this time is the imaginary axis, imaginary part of z, and this is the real part of z. What I mean by RE is the real part of z. Z is the complex number. Okay? So right here, z is complex number. It's a general representation of z, z, z. You're going to do that in your university stage. So R of z means the real part of z. From the first definition, what is R of z? A. And what is the imaginary part of z? Good. This is just a symbol. So let me show you how this Argand diagram thing works. If I have, for instance, z equals maybe a plus bi, it means on the real part, check when x is equal to a. Okay? So x is equal to a might be maybe here. On the imaginary part, when x is equal to b, okay, then this represents our complex number. Does that make sense? On the real parts, in some textbook, you will see they write like this, a plus b, like that. It's the same. Telling you this is the x and y, the real and the complex part, the imaginary part. This is the part where, Damien, where the guy did whatever you think the guy did. This is the axis that is not there. So picture it this way. You have your x and y axis, but there's another, so this is maybe your x axis, y axis, and this is your imaginary axis. So when you plot the graph, you only deal with this plane, because there's another plane you are not considering. Or better still, I put this as x, y, and this could be the imaginary. So we have only been working with this all along. And the answer does not exist, but the answer exists in another plane. What I've drawn here is like the corner of the room. We have one thing here, one axis here, one axis here. That's the meaning of what I've drawn. Okay? They are all perpendicular to each other. So, your real part is the A. This is always the x-axis, and this is always your y-axis when you plot it. But we don't call it x and y-axis in the Argand diagram. We just call it the real axis and the complex one, or the imaginary one. So if we want to represent a complex number in the Argand diagram, it's like drawing a line or a vector. Does it make sense? Where you see where A and B meet and you join it to the origin. Then this represents your complex number C. Does it make sense? We'll continue from here tomorrow. One second? Yes. A little bit later? Yes. Maybe 135. All right.
So, I just want to ask you about the ED.